Madam, welcome, madam. Shivani Gupta, madam. Hello. Audible, madam? Is it audible? Hello, ma'am.
Yeah, yes, sir. Good
Madam,
afternoon, sir.
welcome. Good afternoon, madam. Welcome. Ma'am, 5 minutes, madam. 5 minutes.
Okay, sir, no problem. Okay.
Okay. Thank you.
Good afternoon, Madam. Dr. Shivani Gupta.
Good afternoon, sir.
Good afternoon, madam. In another 1 or 2 minutes, we'll start, madam.
Okay, sir. Okay.
Professor Balamuralidharan, shall we start?
Sir, yes, sir, yes, sir.
Yeah.
Yes, sir. Yes.
Good afternoon, all of you. Welcome back to the afternoon session of COMAT 2023. The invited speaker for this session is Dr. Shivani Gupta. Let me introduce shortly Dr. Shivani Gupta. She is currently a senior assistant professor in VIT, Chennai. She received her BTech degree in computer science and engineering from Madhav Institute of Technology and Science, Gwalior, in 2006, and MTech from RGPV, Bhopal, in the year 2010. She got her PhD in computer science and engineering program at IIT, Institute of Information Technology, Design and Manufacturing, Jabalpur, in machine learning in the year 2019. Her current research interests are on deep learning, machine learning, software, defect prediction, data mining, data analysis, and so on. So I take this opportunity to welcome Dr. Shivani Gupta on behalf of New Research and Innovation Society for a wonderful session this afternoon. Welcome, madam. Now the session is yours, madam.
Thank you, sir. Thank you so much.
Thank you. Thank you.
So, is the screen is visible, sir?
Yes, madam. Yes, madam.
Okay. One. So, good afternoon, all. So, here actually I want to discuss the very important thing that we all doing machine learning research, but what we are doing hit and try method. So we randomly take some data set, download some data set, and then we will randomly choose some classifiers, and we apply those classifier to the data set, and then we identify the accuracy. And after that, we after if the accuracy is high, we use that those classifiers, okay, to classify the instances for the further for the our data set. But actually, I'm here to discuss about the domain of competency of classifier on data complexity space. Okay, so first of all, we need to understand the important things like the predictive performance of the models are basically depends on the various factors, such for example the training data quality, the inductive bias of classification algorithm. So the more I'm more my aim is to focus more on the data quality which we are going to use to apply the classifier. So here the IDC reports that the compound annual growth in the data through 2020 will be at most 50% per year. So this is how that we are using generating data, and we need some method to analyze those data and use those data in research. So we need to identify the quality, and if we are able to identify the quality, then we can use the classifier for the specific classifier of a certain type of quality of data set. But again, the next how to identify the quality, right? So for that we can use data correct we can identify the data set characteristic by using the some measures are proposed by the Ho and Basu, which is called as data complexity measures. So from that we can identify the, I will discuss this, what is data complexity measures. So in particular, like if you are in the field of machine learning, you may know like the class imbalance, class overlapping, class density, high data dimensionality, incorrectness or imperfectness of the training set negatively affect the behavior of the classifier. Okay, so if it's this process is not actually hit and try, that you select some data set, then we will apply some classifier, and then we will see, okay, this classifier is okay for my data set, so for the further research I can use this data set. So but this is that we need to understand why such in such type of in your data set, or what is the characteristic of your data set, so that like for example SVM is working good, why SVM is working good, what is the inductive bias of this that classification, or what is the property of your data. We need to understand that. So here, first of all, I am just introducing the what is classification. So basically, we know that if we have data, what we do, we divide the data into the training and testing set. Okay, and we have some set of algorithms. So what we will do, you can see here, like I have included some of the instances here. In that, the features are name, rank, years, and tenure. Okay, and for that we have some values like Mike, Mary, Bill for name a feature, or you can say attribute also, and the rank is assistant professor, professor and associate, and the tenure is there, years, years, and we have these attributes or features. We can normally we will say features. So what we will do when we will take any classification algorithm, what we apply those classification algorithm to the training set. Okay, and then after that we will train the model. So training the what is the training, what we will do after training the model. So training, when we are training the model, it means actually that model will identify some pattern or some rule. From those pattern, it will, when you will pass the new instances, it will identify the label of those class label of those instances. Okay, I'm talking about supervised learning algorithm. So here, for example, suppose this is our training data and I randomly apply some classification algorithm here, and the rule generated here is if rank is equal to professor or year greater than 6, then tenure equal to yes. Okay, so this is the rule generated by the some classification algorithm over the training data. Now, again, what we will do, we will apply this, the model constructed. Okay, the model, now we already trained the model. Now we are going to apply that model to the testing data to again identify the unseen data. So in case of supervised algorithm, we have the class labels. So what we will do, we will compare those label with the identified label predicted by the classifier, and we will identify the accuracy. Okay, so here you can see that I have some testing data. So I'm applying that rule here. So here, suppose for example, there is one instance, Jeff, professor, and the year of experience is 4. So it will give you the tenure years. But according to this rule, you can see here, so this is like for here or year is greater than 6. Here it's violating that, or because or is there, so it can take anyone. So like that, we will train the model, and then after that, we will apply that for the prediction. Okay, so the problem is actually lie between here, between the construction of the model and after that applying this model to the testing set. Now what is the problem, or what we can do more research, deep research in that area. Like as I told you, the accuracy depend on the goodness of match between the classifier and the problem means the data set. Okay, so here but again you can ask like how we can identify that, how we can identify the goodness of match. So we need to identify the specific reason where the classifier has advantage. Okay, so again the question come, how to identify that region. So for example, suppose someone given me two problem A and problem B. Now you can see here that the problem A, how it looks. Okay, so this is the problem A, and this is the characteristics of problem A. And I randomly choose we have some famous algorithm, KNN, C4.5, SVM, NB. Whenever someone asks us to do some research, we will randomly choose these 4-5 classifiers. So here also I have chosen C4.5 and KNN. And I apply both the classifiers on problem A and problem B. So what I found, like you can see here in the problem A, okay, the first data set, the KNN perform better. And but for the second data set, C4.5 perform better. Now the question arises here, why? What is happening here in the data set? So when applying this to the, you can say like if it's if a data set is linear, then in that case it's very like if you applied KNN, then the performance is good. If the data set is non-linear, but there are other characteristics also, we need to identify those so that we can give a good recommendation system, so that when if someone put data onto and on that recommendation, it will automatically give you some set of classifiers. So no need to try hit and try method. So you when in my college also, I am assigning some of the project to the student. What they will do, they will download some data set from the UCI repository, and they will apply the classifier. Ma'am, I found this result, and this is the new research. So this is not like that. Okay, we need to, because machine learning nowadays is very now we are moved to the deep learning. So we have so a large set of data sets. So we need to understand the property of the classifier and also the characteristic of data set. So here you can see that how the property or the characteristic of data set affecting the performance of the classifier. So here actually, like this is clicked on my mind, and I just I want to inquire like how we can identify the data, the domain of competency of classifier. So again, like someone given a classification, and I want to determine which classifier is best for it. Okay, so it's like not as I told you, like I don't want to randomly choose something, and where I want some systematic way to identify the best classifier. So we have we need to identify the complexity of the data. Okay, and suppose for example I have two complexity measures and I have some set of classifier here, as you can say KNNC 4.5, SVM, and NB. So what I will do, based on that, I will identify the region where the particular classifier perform well. Okay, and then we are able to identify the domain of competency of the classifier for the particular type of problem, the specific type of problem. Okay, now again, we need to understand the source of difficulty when we are dealing with the data complexity. We need to understand the source of difficulty in the classification. So the first source of difficulty when we are applying, when we are doing classification is the class ambiguity, then the boundary complexity, so and the sample size and the dimensionality of the data set. So I am basically dealing with the class ambiguity. So I'm going to tell you what is class ambiguity. So class ambiguity means what there, if we know that in the data set we have class labels. Okay, so whenever some instances are given to you, in the supervised classification, we have class labels. But what will happen, like if there is we have features. Okay, so based on the features we will identify the label of the instances. So if there is a similarity between the features, what will happen, it will confuse the classifier, and those classes are actually confusing the classifier, and it will help to misclassify the particular instance. So here you can see that if I will explain you with the help of these images. So you can see the example here. So the first example is actually the class definition. So this is the shape of the lowercase letter, okay, L, and the numeral one is also somehow same as L when we denote the images. So you can see the properties are like similar. So it's a class ambiguity there. So here also we have insufficient features in the second image. So these insufficient features create it confuse the classifier. So we need to give, because like we are not going to, if we are generating the data set it's good, but we will download some data set and we are using that data set. Okay, so that's why we need to be more careful, because it's entered by some person or taken by some machine, so there may be some problem or some, so that will create the class ambiguity problem in the data set. Now, so how to identify that the data set is ambiguous, or how to identify the characteristics of the data? So we need some measures, okay, because we are doing some research. So we want some metric to measure the complexity of the data. So the one of the researcher Hoen Basu, sorry, he introduced some set of measures which use to measure the complexity of the data set. Okay, and the aim of these data set is data complexity measure is to quantify the properties of the data set, so that we have some measure value, and based on those measure value we can identify the complexity of the data set. And it is mainly divided into the three types: measure of class overlapping, measure of separability of classes, and measure of geometrical and topology density of the manifold. Here, now these measure are actually, like for example, first one is used to identify the class overlapping. But how? So here we will take we take the every feature we will take into the account, and we will see like how this feature are taking part to separate the classes. Then we will merge, then we will make the composite feature, and then we will check the effect of each and every feature of the dimension. The second one is the measure of separability of classes. So in that, we will use the shape of the class boundaries. Is basically is in this we will because it's between we are going to identify the separability of classes. So here we will take the examine the existence and shape of the class boundary. Then the last one is to identify last L-baser are used based on the geometrical, topological, and density of the manifolds. So it is we have take manifolds, and in that we will identify the probability distribution of the given class, and based on that we will identify that the how much the two classes are separated. So these are the three measures and three categories of data complexity measure, and in that we have again some metrics. Okay, that f1 f2 f3 comes under the measure of class overlapping, l1 l2 n1 n2 n3 comes under the measure of separability of classes. Then we have l3 n4 t1 and t2 which comes under the measure of geometric, topological, and density of manifold. So it's because of the time constraint, it's not possible to explain all the measure, but like the main you can go through the paper of Hu and Basu. In that they have introduced some metric formulas, and what is the purpose of each and every measure to calculate the class the complexity or the characteristic of the data. So basically we are going to identify the how the data, how much data is complex. Okay, so when we are applying the classification, so what that so I'm going to just showing some of the results of my research. In that I took 24 problems from the UCI repository, and then I applied these are the 24 data set. Okay, and these are the statistics of the data set. So F is actually denoting the features. Okay, then we have number of classes here and the number of instances. M is the number of instances belong to this data set. So I took this data set from UCI repository. Then why what is the aim of this process actually? Like as I told you, I want to identify the complexity of the data set, so that then I will evaluate the performance of the classifier, so that I can analyze the behavior of the classifier, which actually depend on the quality of the data. Okay, so for that, what like with I applied on this data set, I have generated a binary data set over there, because that now I have created the multi-class data complexity measure, but previously it was only binary. So I converted it to the 1064 different classification data set by combining it to the two set of classes. Then I choose the classifier, four classifier, KNN, C4.5, NB, and SVM, and I computed the data complexity measure over this 1064 data set. Okay, so now what we need to understand, like we need to understand that which of the complexity measure is playing the vital role to or affecting the accuracy of the classifier. Okay, these different four classifier. So this is this you can see here, it's a correlation chart between the data complexity measure and the classifiers. So here you can see that these are the classifiers bar. Okay, and it's correlating with the accuracy of the classifiers. So here you can see that these are the negative correlations. So if the accuracy, if the value of these measure increases, then it will negatively affect the affect the accuracy of the classifier. Okay, so it will, if these measure increases, then the accuracy decreases. So this is the positive correlation. So if here the value increases, then the accuracy also increases. So these here you can see that if mainly if we are talking about the correlation, if the value is more than 60 or 70, then we call it as a good correlation. So here the measure F2, then this one N1, then N3, then after that you can see here N4. If you're taking the 60, then you can see here like L2 and L3, they are playing what role here, which is affecting the accuracy of the classifier. Similarly, this is the same type of, but here you can see that F2 is not playing major role here. But again, the N1, the N3, N4, then L2 and L3 is playing major role, which is affecting the performance of the classifier. So similarly, you can see here, so this is the similarity like what I'm trying to explain you can see here that these measures are playing role to identify how it's affecting the accuracy of the classifier. So we need to understand like, and these measure like you can see that N1, N2, N3, these are actually the measure of the class separability, which we are going to identify based on the class boundary. So here, if we are able to like identify some threshold value or with some value, so we can directly generate a recommendation system, which if some new researcher will come, so we can say that you can use this. So no need to hit and try and use some randomly download some data set. You can download some data set, but whenever you're choosing the classifier, you can choose this set of classifier which is based on this characteristic of the data. So here, so I have included some of the result that you can see here. This is for the first set of measure F1, F2 and F3. So I shorted this by F1, F2 and F3. So we can see here like there is not a clear image for the F2 measure, but you can see the clear, you can the relation between the accuracy and the F1 measure. So you can see here when it's increasing, that the accuracy is also increasing. So it's a positive correlation here for this, for three classifiers, KN and C4.5. But for the SVM, you can see that again we have some data points here which is scattered. So we need to identify like why for this these dots are actually denoting the data sets. Okay, so these points are the dots is particular for the data set. So I have taken 1064 data set for that to identify this result, to analyze the result. So here also F3, you can see some pattern here, but for F2, it's totally random. Similarly, for the second set of measures, N1, N2, and N3, so here you can see some fluctuation. So for N1, some pattern is there, but for N2, it's totally confusing. And again N3, so we can take these like we are able to identify some pattern here, so we can take these N1 and N3 for the further study to understand the characteristic of data and the relation between the data complexity and the classifier performance. Okay, so similarly you can see here also for L3 some pattern is there, but it's actually scattered. And then we for T1 there is a pattern. So this like why what I may what I want to like why I have included this here, and what I want to like explain here, like the quality of the data is playing quite a role here. So you need to understand like we need to understand the characteristic of the data set, and based on that we can apply the classifier. So from that only, this is the conclusion, like we have N1 and N3. If the value is low, it will, all the classifier will perform well. Why? Because it's basically denoting the separability of the classes. So if the classes are not separable, if the value is high, then in that case it will highly affect the performance of the classifier. Then again, if the our classes are highly overlapped, then it will again affect the performance of the classifier. So for overlapping, we can use F1 and F3. Then again for L2, if the value of L2 is increasing, then it will positively affect the performance of the SVM and KNN. Then the last one is the T1 complexity measure. So if the value if less than 0.99, it will give you the best result for C4.5 and SVM. So these are some of the part of my research I have included here. So this will help you. You can go through these research papers if you want to do research in that, because it's now this research is going on because there we have a tons of data set, and people are trying to understand the complexity of the data set, so that we can understand, or you can go to and you can also do the other research, like as I told you, we need to understand the inductive bias of the classifier. If we are able to understand that also, then also we can identify some recommendation system for the specific type of data set. So this is my contact detail. If your my email id is included here. If you want to collaborate, you can mail me, and if your area is related to this, I'm happy to collaborate with you. Thank you so much for listening to me.
Thank you, madam. It's a very nice presentation, madam.
Thank you, sir. Thank you so much for giving me the opportunity for presentation.
Thank you, madam. Thank you very much.
So, any queries? Any like anyone want to ask anything?
Delegates, please ask any clarifications or questions from you regarding the presentation given by Dr. Shivani Gupta, or any clarifications or any suggestions if you need, you can ask our speaker.
Any questions from audience?
Okay, no problem. You can mail me also if you want to collaborate. Okay, thank you, sir.
You can
Thank
send
you,
your.
madam. Thank you.
Thank you. Thank you, madam. Thank you very much.
Okay.
Sir, 3:15 we will start, sir. 3:15 time already given.
Okay, okay, sir. Okay. 3:15 we can wait.
Otherwise, just now we will start, sir.
But the chairpersons, I think they are yet to
Yes,
join.
sir. Anthony, sir.
Yes, come na.
Computer science, 3:15 I said, sir, already.
You said,
Yes, sir.
but without him,
Yes, sir. 3:15.
Anthony, also Dr. Martija also has not joined. Muhammad Golam Martija.
Muhammad
He's
Golam
also,
yeah,
also
sir,
there.
he's there, sir, in mathematics. He's from mathematics.
Oh,
track 2.
Oh, he's for mathematics. Okay.
Yes, sir, track 2, but he will join at 3:15, sir.
Okay, so 3:15
just now I said both members.
Okay, can we call them by
Yes,
now?
sir. Yes, sir. Yes, sir. I call.
You ask them, sir, whether
Yes,
if they are
yes,
ready, we can start. Yeah, yes, Nisha Sanjay, any question? Miss Nisha Sanjay has raised her hand.
No, sir. No questions.
Okay, okay, okay. Thank you. So in CSC session, Balaji?
Yes, sir.
Yes, yes, Balaji. Those who are ready for presentation in track 1, please text your abstract number.